We have discussed subdomain method, and there what we did, we use our trial function u is equal to a sine pi x by l. Okay, there we use a sine pi x by l, and we get the solution. So in that subdomain method, what we did basically, we what we did, we basically try to find the error, and then we multiply the error, and we make the error 0 in the subdomain. And if you have few number of subdomains, so we take that summation of all the subdomain, okay, and we make the error 0 over the entire domain in an average sense. Okay, so here also you observe that in the subdomain method is the extension of our point collocation method, where we assume weight, that is value is equal to 1. Okay, so in that sense we can say this is not a weighted residual method. It may not be categorized as a weighted residual method. Okay, but here our weight is equal to 1, and we are making the error 0 in average sense. In that point collocation method, what we did, we make the error 0 in the selected point. There we did not involve any integration. We make the error in some selected point. We make the error in some selected point, and we try to find the unknown value. Okay, in that subdomain method, what we should do, we used to find a trial functions, and then we try to find the error, and we make the error 0 in an average sense over the entire domain, and try to find the solution. Okay, so here we have few number of domains. So in that case, we have to make that summation of all the domain, and we have to make the error 0 in an average sense, okay, over the entire domain. So here our will be 1, the value of weight function will be error 1. So we have to integrate only for the error function. Okay, so here what we did, we assume a trial function u, that is equal to a plus bx plus cx square. Again, I'm repeating that our trial function should satisfy the boundary condition of actual solution, actual physical problem. Okay, we have solution actual physical problem. So here for the simple separated beam, our u is equal to 0 at x is equal to 0, and u is equal to 0 at x is equal to L. Okay, so in other way, you can say the trial function must satisfy the boundary condition of the actual solution. Okay, so whatever the actual solution, here the y is there, that whatever the boundary condition it is satisfying, the same boundary condition, the trial function must satisfy. Okay, or other word, you can say trial function must satisfy that under condition of the actual physical problem. Now, what happens if we put x is equal to 0? We will observe that our x is equal to 0, our trial function value also will be 0. So u is equal to a plus bx plus cx square. So our value of a will be 0. Now, if you make u is equal to 0, at x is equal to L, you will observe that b, okay, that you will get BL, that is equal to plus CL square is equal to 0. From there you will get B is equal to minus CL. Now if you put the value here, you will get the trial solution like this. Here you can obtain trial solution where you have only one unknown parameter. Okay. So now what we will do? So we get our U, that is equal to C x into x minus L. Okay. And now what we'll do, we try to find the double derivative of u, and we put the value, the equation, okay, instead of y, instead of actual solution, there will be our trial solution, and this value will not be 0 now. Okay, so this value we used to call the error, and what we will do, we will basically find the error 0 over the subdomain in an average sense, and it will be 0 like this. So here w, that weight function, is equal to 1. Okay, so basically we have to make the error 0 in the subdomain average sense. Since we have only one subdomain 0 to L, we will make that error 0 in the domain. Okay, so once we do the integration and make it 0, what we'll observe, that value of C is coming as m0 by 2 ei. Okay, now already we obtained our trial solution is like this. So our trial solution, actual trial solution, will look like this. U is equal to m0 by 2 ei x into x minus L. Okay, now again we already know our actual solution is this one. Okay, now if you plot this value x and y, you will observe that basically this value is overlapping with each other, so there is no error now. So now here you can observe that our trial solution, okay, replicating our actual solution. Now again, I'm saying that accuracy of the trial solution always depend on how well you can assume our approximate solution or the trial solution. Okay, accuracy of that subdomain method or any weighted residual method depend how well you can choose your trial function. In some cases, you'll observe your polynomial trial function giving good result. Okay, in some cases, you'll observe our trigonometric trial function giving good result. Okay, so now it depend on that which method you are using and how well you are able to choose the trial function. Depending on that, your accuracy will vary. Okay. So what we have discussed till now, we have basically various weighted residual method, Glerkin method, least square method, Ploynomial collocation method, and subdomain method. In all the previous video, I have tried to discuss this method. Okay, and in this current method, we discuss current video. We have discussed subdomain method or subdomain collocation method. We make the error 0 in average sense over the subdomain, and we take the summation of all the subdomain, and we get that 0. We get the error 0. Okay, and we are getting the solution for that. Okay, so now accuracy of the solution depend on that how well we are able to find that approximate solution or the trial solution. Okay, I hope you get some idea. Thank you.